Welcome back to section 3.7. We're dealing with applications of derivatives and we're dealing with these optimization problems. In part 1, I basically went through the procedure for doing this and now I'm working examples. I have one more example to work through, which I saved for this one because the other video was getting a bit long. So let's jump to this one. Hopefully you've looked at this already. If you haven't, we have a triangle in, this is an isosceles triangle inscribed inside a circle with a radius of 6. And we want to find the area of the largest triangle we can do this way. So with this diagram, we've kind of labeled isosceles, so we've labeled our congruent angles here, calling this angle alpha. And here we have the altitude is going to be, in this case, 6 plus h, because what's going to change is how far down we're taking this, or how far up we go this way, if you want to look at it that way. So take a look at this one, give it a try. You can either solve this by looking at h, the height, or we can look at it by this angle alpha. So I'm going to work it using h, but I would recommend you try it this way as well if you want to. Pause the video, give it a try, and come back and we will solve it using basically h as our variable of interest here. So when we look at this, we want the area of a triangle. And if our two area equations we have area equals 1/2 base times height, or we have area equals 1/2 AB sine of C. This is the one we would use if we're working with alpha. We're dealing with going to be using this altitude on here, so we'll use this one, except this h is not this h, so I'm going to rewrite my formula to call this whole thing, we'll call this A, and we'll call this B. So I'm going to use my formula, area equals 1/2 AB. Because we want the largest area, so we have this as a formula written in terms of area. Now, again, I have two variables here, and I need to get this down to one variable. So if I look at this, I have A is really 6 plus h. So to figure out A, we get h involved here. So we really have another variable to think about. So what can we look for B? For B, I'm going to use this triangle right here. Because on this triangle, I know this side, I know this side, I know this is a right angle, because it's an isosceles triangle. The altitude of an isosceles triangle is going to make a right triangle. So I can use that fact to come up with 6 squared equals h squared plus b squared. So I could rewrite this, or, oh, that's not a really great color. Let's do it there. B is going to be the square root of 36 minus h squared. In this case, I can get both A and b in terms of the variable h. So I can rewrite my variable or my area equation to say area equals 1/2 times 6 plus h times the square root of 36 minus h squared. And while this is not pretty, it is in terms of one variable, so we can go ahead and solve this. Now, before we go any farther, we're going to start saying, what's my feasible domain? Well, we say h is how far we're going past this center point, so h has to be less than or equal to 6. Now, what happens if we go this way? We could still use this as 6 plus h and count this as a negative h, and we could take triangles going up this way, so we could go all the way to negative 6 if we needed to. So let's jump at this and find the derivative. Derivative, we got product rule, and we have chain rule. So we got to take care of both of those. We officially have chain rule here, but this is a trivial case. So to find my derivative, I'm going to take out my constant. I'm going to take my 6 plus h times the derivative of this. It's going to be the chain rule. So I'm going to have 1/2 36 minus h squared to the negative 1/2 times the derivative of 36 minus h squared, which is going to be a negative 2h. And I'm going to add to that the derivative of 6 plus h, which is just 1, times the square root of 36 minus h squared. Now all we have to do is find out where that equals 0. So let's clean this up a little bit. So this is 6 plus h over 2 square roots of 36 minus h squared. Oh, and this is times a negative 2h. Let's just... Oh, that's way too big. Yeah. Get this eraser we can work with. So we have a negative 2h times 6 plus h, so I'll make that... Oh, that 2 can cancel out that 2. That will be nice. So we can get rid of that one. And so we have a negative h times 6 plus h. So that would be a negative 6h minus h squared. And then over here we have the square root of 36 minus h squared. And let's make a common denominator. So we'll take this times the square root of 36 minus h squared over the square root of 36 minus h squared, giving me a prime equals 1/2 negative 6h minus h squared plus 36 minus h squared all over the square root of 36 minus h squared. Again, when we're looking at this, the denominator is 36 minus h squared, so I can't be, well, or where is this going to be 0, 6, or negative 6? These are my endpoints of my interval, so I'm not worried about that. I just need the denominator to equal 0. When I do this, let's clean this up a little bit. We have 1/2 times Negative 2h squared minus 6h plus 36 over my square root. I'm going to take out a negative 2. So this is going to be the opposite of h squared plus 3h plus 18 over the square root of 36 minus h squared. Okay, so I need that to equal 0. Let's clean off a little work so I can space so I can get another more room to work on here. If you still need some of this, pause or rewind the video. I still want that area formula. So let's do that again and be a little cleaner with it. Okay. And move this over here so we can work with it. Confirm. So when I set this equal to 0, I only have to worry about this numerator. So I need 0 to equal h squared plus 3h minus 18, because I messed up on that one. That's a minus. I suppose I can make that neater for you. Okay. The really annoying thing is that's not even a message to me, that's a message to my wife. But I still get those notifications. Sorry about that. This is h minus 6 plus 6, h minus 3. So 6 times negative 3 is negative 18. 6 minus 3 is positive 3. So h equals negative 6 or h equals 0. Sorry, not 0, 3. So I'm going to check my area at those 3 values. At my endpoints, so area at negative 6, area at 6, and area at 3. Well, if h is, again, if h is negative 6, this is 0, so the area is 0. If h is positive 6, 6 squared is 0, or 36, so this is 0. So my area is 0 at the endpoints. So I just look at 3, I plug in 3 into my formula, and I'm going to get 46.71, whoops, can't even read my writing, 765. So the largest isosceles triangle is going to have an area of 46.765. And this is going to be when the altitude equals 6 plus h equals 9. But we're not asking that. We're just saying what's the area of the largest triangle is 46.765. I would challenge you, see where some of your geometry skills are at. Try to redo this problem, but instead of doing it in terms of h, do it in terms of alpha, and see what you can do to try to do that problem. These are these problems. Again, we find the primary equation, our primary formula. In this case, we have more than one variable over here, so we had our secondary formulas that we plugged into the primary to get something down to one independent variable that we could take the derivative, set it equal to 0. Then we check to find the critical points, and then we are going to check the value at the endpoints and all critical points to see which one is the largest. So, have fun with that homework.